Okay, so um, welcome to my talk about microservices with Java Spring Boot and Spring Cloud. Thanks for showing up. My name is Eberhard Wolff. I'm a fellow at InnoQ, a software development company and consultancy in Germany, and you can also see my Twitter handle there. I guess one of the reasons why I'm actually standing here is because I wrote this book, which is a German book about microservices. If you're interested, there's actually a copy right here, and I translated it to English too. So for the rest of you, you can also take a look at that. And I do have a copy of the English version here too. Also, there is this small book. It's about 30 pages, and it talks a little bit about what microservices are and why you would want to use them. And you can download the ebook for free from the URL. And I've actually, so if you're more into, dead trees, then this is for you. So I brought 10 paperbacks, and I'm happy to offer them to you after the talk. So just come to the front, and the first 10 would get a paperback copy of that. Okay, so before I talk about concrete technologies, I would like to spend a few slides on what microservices actually are. So they are somehow small, but I think the most important property of microservices is that they are independent deployment units. So if you use microservices to modularize your application, each of those modules, each of those microservices can be deployed on its own. And that has quite a lot of benefits. So for example, you can roll out a new feature by just rolling out one microservice instead of rolling out a huge complex system. So to me, that's like the main property of microservices. And if you think about it more closely, how do you actually do that? Then you realize that you have to have individual processors or virtual machines. And that means that you can use any technology to implement microservices. So if you want to have independent deployment, you have individual processors, and those can be implemented with any programming language and any platform, and therefore also any infrastructure. So you have a server and a microservice running on that, and another server with another microservice, and these are parts of your system. Now, how do you make those individual systems to a whole? Well, you need to collaborate. So I argue that microservices should actually have an HTML interface or a UI, so you can have links. So if I have an order and I want to see details of the customer, there might be a link, and I just link to a different microservice. I can have data replication. So I can replicate the data of the customer database or whatever to have it in my own database. Now you might wonder why you would want to do that, but it turns out that this is not too uncommon. If you have data warehouses, for example, they do a lot of data replication because they have just very different ways of accessing the data, much more read intensive than what you have in your online system. So if you have a microservice that is built for analytics, I think it's quite obvious that data replication might be a good choice. Or you can have REST or messaging. So this slide actually tells you that microservices are more than just small REST-based services, and that there are quite a few alternatives, and that's why I included it in my presentation. Now, I'm not going to talk a lot about microservices. Actually, this is the last slide about what microservices are and how they behave. The rest of the talk will be about an infrastructure. Now, why would I have a different infrastructure for microservices? I guess one of the reasons is because there are just a lot of services that you need to support. Each and every of your applications is divided into a lot of microservices, so there are just a lot more services, a lot more deployable artifacts that you want to bring into production. So it should be easy to create a new project. If you have an infrastructure that allows you to easily create a new deployable artifact, then that's quite a huge benefit for microservices because you will have quite a lot of them. And if it's easy to create new projects, the microservices will probably stay small because developers will rather create a new microservice than grow an existing microservice and make it really, really huge. Then we need to have some kind of REST, so we need to have some protocol. We would need to have some messaging support. And another very important point is that we need to have uniform operations. So if you really want to have a lot of microservices in operations, then, and each of those microservices behaves slightly different and has a different log format and behaves different in terms of monitoring and so on, then you will have a lot of effort, and that is probably not what you want, because then you will spend a lot of money on operations. So the wiser choice seems to be to have a uniform way that every microservice concerning operations behaves the same, and that way you can save money and effort. So, of course, I claim that Spring Boot and Spring Cloud actually solves many of those problems. So let's take a look at Spring Boot first. So actually, you can find that demo, which is very, very simple on my GitHub page. Actually, it's really, really simple. So if you look at it, there is just one Java class. There is a test that I only need because I'm not smart enough to write bug-free software from the start. And there is a POM for Maven. So let's take a look at the code first, or let's take a look at the application as it runs. So let's start it. And you can see that the application is running here. And I can actually curl into it. And I get the result. And as you can see, there is a Tomcat running here, and there is some other stuff going on. At the end of the day, a full Spring environment is being started, including the Tomcat web server, as well as the dispatcher servlet and all these kinds of things. So let's take a look at the code. Well, the code is actually very simple. So if you look at it, this here is just a straight Spring annotation. So as you can see, it says org Spring Framework Web Bind Annotation REST Controller. So this says this is some kind of web controller, and the content, the result of such a method like this one will be returned as the HTTP response body. So hello is the body. And this here says that this method should be called when an access to the root is done. And these are all Spring annotations. So up until now, add REST controller and add request mapping, all these kinds of things are just Spring. So there is nothing Spring Boot specific that we've seen so far. The Spring Boot specific stuff here is the add enable auto configuration, which basically says create an environment where this application can run. So this is why a Tomcat is started, the Spring stuff is started, and so on and so on. And this here at the bottom says, please start this class. So that's the other Spring Boot specific thing. And then there is the Maven POM, which is quite simple too. So basically says, inherit from the parent POM, use some sensible version of Java, and here is the only dependency. There is another dependency, but that's for tests only. And there is a Maven plugin here, and that's it. So it's not a lot of stuff here. Now you might wonder why we even get the Tomcat server in there. That's because we have a dependency tree, and somewhere in here, right here, is Tomcat. So basically, what I said is, I want to create a web application, and what Spring Boot said, well, that's great. So we just include all the dependencies that you would need in versions that actually work together, and that is why I ended up having Tomcat in here without actually deciding about the version myself. That's done for me by Spring Boot. So that's a very simple application. let's sum up what we've just seen. So what we've seen is there is a POM XML. You could also use Gradle or ART. There are very few dependencies. Actually, there is just one besides the tests. There is a plugin configured, and all the versions of all the dependent libraries is actually defined for me. And what we've also seen is that REST is integrated. So there is support in Spring MVC, as we've seen with add REST controller, add request mapping, all very sophisticated and quite handy if you really want to do REST. There is also support for JAX-RS if you're more into standards, and Jersey is supported, so you would just add another Spring Boot starter, and then you could use Jersey. So apart from that Spring Boot starter web, which I used, you can have quite a lot of other starters that would allow you to use different types of infrastructure. So that's it for REST. Now, concerning messaging, I haven't shown it to you in the code, so you need to believe me that there are quite a few Spring Boot starters that allow you to use basically anything that you can use in Spring 2. So for example, there is AMQP support, which uses RabbitMQ. AMQP is a wire level framework that defines what is actually used on the wire as a protocol for messaging. There is a starter for HornetQ, which is the JMS implementation, the Java messaging service that is the standard in Java EE. There is also ActiveMQ Artemis support. And this is all what you get concerning Spring Boot starter. So you would just need to add a Spring Boot starter, AMQP for example, to use RabbitMQ if you want to do that. Concerning the API, there is the Spring JMS abstraction, which gives you message-driven POJOs. So just plain Java objects that are scalable, so they can handle multiple messages at the same time. Also, there is support for simplifying sending JMS messages. And of course, you can also use other libs. So apart from the Spring Boot starters that I've just shown you, you can basically do whatever you can do in Spring or Java. So you can just add any library that is there in Java and use it with the Spring abstraction and so on. It's just a little bit more complicated, and maybe you need to do some manual configuration, but that's it. So concerning the infrastructure, what we've seen now is that it's actually very easy to create a new project. So you just need to have some kind of build file like the POM XML that I've shown you. It's also very easy to use REST because there is support for Spring MVC that does REST, and there is also support for JAX-RS. There is support for messaging, AMQP, HornetQ, or your favorite whatever different library. So this all works. So the next question is, what about deployment? So concerning deployment, it's actually very easy. What you can do is you can just package everything in one executable jar, and that's it. Then you're done. You can also use WAR files if you want to use traditional application servers, which might make some sense if operations is already used to application servers and that's what they want to do. But otherwise, these executable jars are actually quite nice. And that can be done using Maven, ART, or Gradle. And there is also support for configuration there. So let me show it to you. So what I've done is I've created a virtual machine here. And what we are going to do is we are going to let me see that I get the paths right. So we can just package the whole thing together. So this will create the executable jar file. This is why I have configured this plugin. So this plugin is responsible for actually creating that executable jar file. And I can just start it. If there you go. So it's just the application that starts, and I've killed it because I'm not interested in that. So let's imagine that I want to bring that application on my on some kind of server. So the only thing that I need to do is I need to copy over that jar file, and then I can just start it. So I can just say, okay, please start this jar file, and that's all. It's self-contained. So it includes the Tomcat in the version that I was using during development, and so on and so on. As you can see, in this example, it runs on port 8080. So if you look at the second line from the bottom, it actually says that it's listening on port 8080. Now let's imagine that this server, for one reason or another, has to be configured slightly different. Let's say that we want to map the server port to 8042. So what I've done is I've created a file in called application properties with the only editor that I can use, which is Emacs. And now the application runs on port 8042, as you can see. There are quite a few other ways that you can configure that application too. So for example, you can use environment variables if you want to do that. You can package an application.properties in the system itself, in the jar file, and so on and so on. So for deployment, it's actually very, very simple. All you need to do is you need to have a server that has a JDK or a Java runtime environment. Then you need to put in the Java, your jar file, and then you can use the standard configuration mechanisms to change the configuration in any way that you like. And that's it. So, and of course, in real life, I would do that in an automated fashion. But you can imagine that this is quite easy, right? Because it's just a few lines in a script that you want to write. So all you need to do is you need to install a basic machine, you need to install Java, you need to copy over the jar file. You can actually also make it a Linux service, which is quite nice, by just setting a link. So if you set a link in this rc.d directory, then this application will become a Linux service, which is nice because you can manage it with Linux service tools, and it's also automatically started if you start the VM. And you can create an application properties that does some special things. So concerning the infrastructure, I think I've shown that it's actually very simple to deploy those applications, because you just need to copy over the jar file and have a Java runtime environment, and that's it. So I don't think that you can get any simpler than that using Java. So what about uniform operations? In Spring Boot, there is something called Actuator, and that provides some information about the application. It does so by using HTTP and JSON, or you can use, it uses the metrics framework from Dropwizard. So that way, it can be evaluated by monitoring tools such as Graphite or Grafana. So you can just send your metrics to such tools by providing a few command line options, or you can use the data that is provided to you by the HTTP interface and read out the JSON yourself. So that's up to you. So let me show that to you. So I have a slightly more complex application here, which is this one. And again, I'm just going to start the main class here. And what I've done is I have added this dependency. So this is a different application, therefore it has quite a few other dependencies too. So for example, I'm using Spring Data JPA, I'm using Timely for HTML templates and so on and so on. But this is what I want to focus on, the Spring Boot Starter Actuator. What I can do now is I can actually open this web page, which is a static page. And now I can read in some metrics, for example. So this gives me an overview about the memory that is being consumed and these kinds of things. So if I want to use it in a more sensible fashion, I could curl it and pretty printed it. As you can see, I get free memory here, I get the system load, these kinds of things. And if I actually access the application itself, let me do that a few times. Then I should get a few counters here. So I get results about how often the web page was accessed and what the response times were like and all these kinds of things. And this is basically for free, right? So I just added Spring Boot Actuator, and you can also extend it, so you can use your own metrics and add that too. The main point is it's all uniform. So if you use Spring Boot, then you have the same JSON HTTP front end that you can use, and you can also pass in the data to your favorite monitoring solution in the very same way for every application. So, and if you are interested in that in more detail, I've actually created a demo that you can find on my GitHub account that does logging of such an application and puts it into the Elk stack, Elasticsearch, Logstash, Kibana to analyze and store these logs. And there is also a demo there that uses Graphite to show the results in a monitoring tool. So those are, if you're more interested into it, you can look at that and see how that could work in a real, more production-like environment. So what I'm trying to say here is that Spring Boot actually also supports uniform operations because all of your Spring Boot applications will behave the very same way concerning monitoring, logging, and so on. So you just need to plug it in to your monitoring solution and your log analysis tool, and that's it. So it's not such a big deal to operate 10 or 20 microservices if they all behave the same way concerning monitoring and operations, and using a technology such as Spring Boot, that's very simple to do. So now the question is, why would I even talk about other technologies? But I still need to talk about Spring Cloud. And Spring Cloud is first of all based on Spring Boot, and it's actually a very huge project. So it supports quite a few technology stacks for microservices. It supports quite a few different cloud environments. So there is support for some features of the Amazon Web Services, as well as the Cloud Foundry cloud, and so on and so on. What I want to focus on in this presentation is the Netflix stack. So Netflix is somewhat famous for open sourcing its microservices tool suite, and that has been integrated into Spring Cloud. So what I am going to talk about here is Spring Cloud Netflix, which is a sub-project of Spring Cloud. And in particular, I will talk about Zool for routing, Ribbon for client-side load balancing, Eureka for service discovery, and Hystrix for resilience. So first of all, let me talk about coordinating microservices. So we are going to have a lot of microservices, and they need to somehow find each other. So here is a microservice, here's another microservice, they want to talk to one another. So let's imagine that the order microservice wants to get access to the customer data. So it needs to have some way of figuring out where this customer microservice is actually located. And that is where Eureka comes in. Now you might wonder why you would want to use Eureka. At the end of the day, you could use, for example, DNS to do some kind of service discovery. So you could say, okay, here is a server, it's called customer, and through a DNS lookup, I will find the IP address of that server. And that's actually a sensible approach. But there are some reasons why you would want to use Eureka. First of all, it's a REST-based service registry. It supports replication out of the box. And it supports caching on the client. So there is a Java library that allows you to use the Eureka server, and the data of the server is cached on your local machine. And the benefit is that if you do a lookup, it will not go across the network, it will just stay on your machine. So it's very fast, and it's also resilient. So if one of those servers crashes, it doesn't really matter because there are still a few replicates and there is the cache on your client. At the same time, it's not really consistent. So the problem that you have is when you do replication, some servers might not have seen all the updates. And in that case, those servers will have outdated information. And Eureka just returns that outdated information, which I think is a sensible trade-off, because you will notice that the data is outdated. So you will just get an IP address where there's actually no one listening, and then you can go back to your service discovery and redo the whole thing. Eureka is also important because it's the foundation for the other services. So we will talk about that pretty soon. So how do you do that? How do you use Eureka? So there is the Eureka client, and in order to use it, you would need to add an annotation like add enable discovery client to your code, just like add enable auto configuration, which we've seen before. This is a generic annotation, so using this annotation, you will actually be able to use the application with different service discovery technologies. So for example, there's also support for console in Spring Cloud, and you could use that too. Or you could be more specific and say, okay, I really want to use Eureka here. Then you need to have a dependency to Spring Cloud Starter Eureka, and then the application is registered automatically. Sounds great, right? Now, you might wonder how this actually works, because at the end of the day, you need to have access to one specific Eureka server, right? And somehow you need to find that server. And actually, this is something that you still need to do. So in your application.properties, which is the standard Spring Boot configuration, you need to say, this is the server that you register at. You can also include username and password there. You can configure it. So for example, using this configuration, the interval between updates is actually lower. So that way, changes, if a new server comes up, are propagated more quickly. This is better for testing purposes. For production, it's probably better to go with the default, which is higher. I think it's like 30 seconds. And because in production, you don't want to have that much network traffic just for service discovery, I guess. Then you will need to give a name to the application, so catalog in our example, and that name would be used to register the application at Eureka, so in capital letters. So it would be called capital C, capital A, and so on in Eureka. Could be looked up there. You need to have a unique ID for load balancing, for example. And, well, I use IP addresses because the environment that I'm running in is Docker, and Docker has some issues concerning host names. And that's it. So there is an application of properties that you set up in this way. You add the dependencies, as I've said. You add one a single annotation, and then you're done. Now, if there is a client, there should also be a server. And concerning the server, you have to write it yourself, which is actually very simple, because all that you do is you take your average Spring Boot application and add enable Eureka server, and you add a dependency. Why would you do that? Well, actually, if you look at what Netflix does with Eureka, there is a prepackaged server, so you could use that too. The benefit of using this approach is that you can add features to the server. So for example, you can use Spring Security to add some kind of security measurement to your server. So, user-based is some kind of authentication or authorization using a servlet filter, for example. So that's, I guess, the benefit. And if you do that, and if you open that one in your browser, you get something like this, which basically says, well, the server's running, and at the bottom you see that there is an instance of catalog registered at a certain IP address, there is an instance of customer registered at a certain IP address, and so on and so on. So that's basically what you get, and then your clients can access those machines. We will talk about how you access those machines and how you do the resolution later on. That's tied to ribbon and load balancing. So this is the first thing. You need to have some kind of service discovery. Another thing that you can do is you can add some kind of routing. So why would you do that, or what's the problem here? This is something that Zuul does. And the idea is I provide one URL to the outside, but internally there are quite a few microservices that talk REST, and I want to send a request to one specific microservice. Now again, just like with Eureka, there are alternatives. So one very obvious alternative is to use a reverse proxy and use that for routing. Why would I use Zuul instead of a reverse proxy? The one feature that a proxy will probably not provide you is filters. So in Zuul, you can create a filter that says, if a request comes in for Eberhard Wolff, well, we go to that server over there because he currently has some kind of trouble. We want to analyze that, and the server over there has more debug information or whatever. So you can have any kind of algorithm to send requests to any microservice, even to any specific instance, and you can extend that using your own code or Groovy code or what have you. So that's the reason why you might want to consider Zuul instead of a reverse proxy. So how does that work? Well, here's my Zuul proxy. Here are some microservices for order, customer, and catalog. And if you use the Zuul proxy, then there is an automatic mapping to the registered services. So a request to customer goes to the customer microservice without any configuration. Now, you might say, okay, well, this is somewhat stupid because I just said that you want to have different rules for sending requests to different services, but you can still do that. So you can still add filters to that if you want to, but there is a sensible default here. How do you create such a proxy? Well, it's very similar to what we've seen with the Eureka server. So you just add, you have your straight normal Spring Boot application. In this case, there is an annotation called add Spring Boot application here, which does, well, the same thing as an add enable auto configuration plus a little bit more. And then you just add enable Zuul proxy, and that's it. And you would need to have the dependency to the Zuul server, and that's it. And then you can still add filters and what have you. So that's it for services. Now another topic that might be interesting is configuration. So you have a lot of different services, and I argued that using application.properties, there is already a configuration mechanism in place. However, the Spring guys decided that they want to have a special service that does more than that, and it's called Spring Cloud Config. So how does that work? It's a centralized configuration. There are quite a few. There are a lot of ways to extend it. So, for example, you can have your configuration in a Git repository, so it might be versioned. And the one thing that is very special to Spring Cloud Config is that there are dynamic updates. So if you do a change to your configuration, it will be propagated to all of your services, and they will change accordingly. This is a feature that has been requested for Spring applications for quite a while. So ever since I started with Spring, which is now like 10 years ago, this has been a request. Like, you know, there is a Spring configuration. If something changes, it should be changed in the running application. And in that way, Spring Cloud Config is actually quite nice because it does that. It does that in a way that some Spring beans would be shut down and restarted with the new configuration. So, for example, if you do a change to your, I don't know, to your database connection pool, then the database connection pool would be restarted. So I think in a way that's actually quite nice. And as I said, you can also version your configuration. But I'm not sure whether that's really what you want. If you look at the world that we are living in today, usually there is a cluster of servers. So if you have a new version of your software or a new version of your configuration, you can actually start a new cluster with that new configuration, test it, and see whether it actually works, and then slowly migrate over to the new version or to the new configuration. This is a concept called immutable server. And the idea is that you don't update your servers, you just create them from scratch. And the nice thing about it is that they are reproducible. So you can be absolutely sure that the server as it runs in production is reproducible because it's a freshly installed from scratch server. And you can create configurations like application properties with a lot of DevOps tools where you can, you know, pass in variables and have these kinds of things. And I think that's probably the more sensible approach. And the dynamic updates are not that much needed anymore because you can just kill the server with the old configuration and start a new one with the new configuration. So updating the server by itself, I don't know whether that makes a lot of sense. Similar thing concerning Spring Cloud Bus. So that's how you push configuration updates. You can also use it for your own messaging. I think it doesn't make a lot of sense to use that if you don't use Spring Cloud Config. So I would rather use my own messaging solution that is independent from Spring. So that's it for configuration. There is one final thing that is security. If you look at a microservices system, there is actually a challenge concerning security, because what you want to do is you want to log in. You want to say, this is me, I'm Eberhard Wolff, this is my password or whatever the credentials are. Please let me access that system. And, you know, I would need to have something that actually says, yeah, this is really Eberhard Wolff. And then I need to go to one microservice and tell him, well, you know what? I want to create a new order. And that microservice should decide, well, Eberhard Wolff is allowed to do that or not. But that microservice should do it because that microservice is responsible for handling orders, and whether someone is allowed to create an order or not is part of that logic that that microservice should do. So if you do security in a microservices-based environment, you need to separate the authentication that proves that you are actually Eberhard Wolff from the authorization that tells you whether someone is allowed to do something. And the authorization should be done in each microservice. And Spring Cloud Security does that by providing a single sign-on using OAuth 2. So you would log in and say, I'm Eberhard Wolff, here's my password, and in return you get an OAuth 2 token. And that token is forwarded through REST templates and so on. It's also forwarded if you do routing in Zool. And I think that's very valuable because this approach to security is basically what you need in a microservices environment. And this is implemented for you. So this is sort of the overall system. Microservices can talk to each other now because there is service discovery. We have seen some ideas about configuration. We've also seen how to implement security. So the overall communication infrastructure is in place now. In the microservices themselves, there are a few other challenges. And in particular, where microservices talk to each other. So, you know, there might be some kind of gatekeeper, some class that encapsulates the communication to the other microservices. And this has to do quite a few things. So for example, you need to have some kind of load balancing because you might have quite a few instances of the other microservice and you might want to decide which of those instances should deal with a specific request. And that's what Ribbon does. Ribbon does proxy-based load balancing. No, it does client-side load balancing. Proxy-based load balancing is actually quite the opposite. So that is probably what we are used to. There is a load balancer, there are a lot of servers, there are a lot of clients, and you have some kind of centralized load balancer. This might eventually become a bottleneck because every request goes through that one load balancer. And it's a single point of failure. Of course, it might be highly available, but it would be better if you could avoid that single point of failure. And if you have one load balancer for all microservices, well, the configuration will be quite complex because there are a lot of instances of different types of microservices. Instances come and go because they crash, because there is more load and new instances are started. So that's not really, I guess, the most intelligent solution to load balancing in microservices. And that is why Ribbon does client-side load balancing. So what does that mean? Well, here's my client. And inside, so that would be the calling microservice, the microservice that calls other microservices. And in there is a load balancer that talks to all the servers. So it's a decentralized load balancer. And this is no bottleneck because every client decides which server to talk to all by itself. So there is no bottleneck because it's all decentralized. And it's also resilient. If the load balancer crashes, well, it's just part of the client. So it doesn't matter. The other clients are not influenced at all. And it can even do some kind of intelligent load balancing by considering response times. It's just like in real life. If someone does the work very quickly, you just give him more work until he stops doing it quickly. So that's how you can deal with that problem. Of course, data might be inconsistent because we are using Eureka behind the scenes here. Yeah, and that's pretty much all there is concerning Ribbon. Using that is not that hard. So what you do is you say, okay, this is a Ribbon client, and then in your code, you can use, for example, the REST template, which is standard Spring stuff for doing REST. And then you can access a URL, and that one over there stores, it's actually a Eureka name. And that way you get the interface to Eureka. What else is there? There is, besides load balancing, there's also resilience. Resilience is done using Hystrix in the case of Spring Cloud. So what is Hystrix? well, it enables resilient application. And one of the things it does calls to other systems in a different thread pool. So the problem that you have is you talk to another system, that system somehow misbehaves, and then you're stuck, and your thread is stuck. And eventually, the system that calls me will also get stuck. And then it all crashes at one point, because that system crashed, my system crashed, because I crashed, that system crashed, and everything, nothing is working anymore. Hystrix solves that problem by doing the call in another thread loop, and that way it won't block the request handler, and you can implement a timeout. So you can just say, okay, after 10 seconds, I don't assume that I will get any kind of response anymore, so I just stop calling that system. And that's much better than, crashing and making the next system crash, because you can say, okay, not available anymore, and have a sensible error there. Hystrix also implements the circuit breaker, which basically says if the system over there fails, and it fails constantly, then I open the circuit breaker and I do not forward calls anymore. I forward calls again after some time, and then I will see whether that system works again. So it's like real-world circuit breakers, and the reason why you want to do that is because the other system won't be swamped with requests. So if it fails, my circuit will open, and if the system comes up again, at one point I will close my circuit breaker again. So will the other systems, but they will do that at different points in time. So the system, once it comes up, isn't swamped with all the requests. Instead, it gets slowly used to the requests again, and also I can much more easily create the timeout, because I just say, okay, it doesn't make any sense to call that system anyway, so I can fail even faster. Using that is actually not that hard. So here is an access to another system, and what I do here is I say, okay, this is the Hystrix command, so I get all the timeouts and so on, and I add a fallback in this case. So if the system doesn't respond, I call actually a different method, and that method returns an internal cache, so that even if that system over there fails, I can still work, and that way my system is resilient against failures of that system over there. So let me draw the conclusion here. The infrastructure that I've shown you, Spring Boot, allows you to easily create new projects. REST and messaging is supported, and deployments are quite simple. You just need to copy over the jar file, and it provides you uniform operations. Spring Cloud adds some more features to it. So there is Eureka for service recovery, Zool to route calls, there is support for configuration, and Ribbon for load balancing, and Hystrix for resilience. If you're interested in more of that stuff, there is a demo that you can basically run. It should be quite easy to do so. So it runs on Docker and uses Spring Boot and Spring Cloud. So that's something that you can experiment with. Those are the demos that I've actually shown you. This is Spring Boot plus Elk Stack, Graphite, and so on. You've seen the links in the presentation before. This is the link to the Spring Boot framework itself, to Spring Cloud. There are some guides that show you specific features of Spring and Spring Boot, so maybe you want to look at that. And there is also, of course, my Microservices book, which you might look at. Okay, so thanks a lot for listening. We have, I don't know, I guess we have time for like 1 or 2 questions. So are there any questions? There is one. So the question is whether there is real life experience and whether this is something that I see at clients. So architectural approaches like this we've been doing for quite a while. Concerning Spring Boot and Spring Cloud in particular, yes, we do have a few clients that are using that, and you can handle that. There is competition, so if you look at HashiCorp, for example, they have quite a few competing technologies, so that is definitely worth a look. And I think it's important to, I guess the main point that I want to make here is you need specific technologies like service discovery, you need some kind of resilience and so on. Whether you want to use Hystrix, Eureka, DNS or whatever, that's up to you. But you should take a look at those technologies. I think the Netflix stack is quite usable, and Netflix is using it itself. So of course, there is quite a lot of experience with it. So it might not be the worst option. Okay, thanks a lot for listening. I'll stick around here. And as I said, there are the paperbacks, so if you want to come to the front and collect one. Okay, thanks a lot.